For this question, we're going to be using substitution, and then once we've subbed everything in, we'd end up having to use integration by parts as well. So we could set u to be equal to sec x straight away, but that'll be a bit more complex because when you differentiate sec x, you end up with sec x tan x, and when we replace the dx and we put in that sec x tan x into here, it gets a bit complex. It's doable, it's not too difficult, but it's just a bit longer than if you were to do this instead. If you were to change the sec x into 1 over cos x, or cos x to the minus 1. The ln of sec x, which is what we have here, that can be rewritten as ln of cos x to the minus 1, and then because a ln b is just equal to ln b to the power of a, we can just bring down this power, put it in front, and then this becomes minus ln cos x. So again, that's just bringing this power out in front. So the ln sec x that we have here becomes minus ln cos x. Let's do that now. This becomes minus, I'll bring the minus out in front. This is the minus from the minus ln cos x. So minus sin x ln cos x dx. Now, this is better because now we can set u to be equal to cos x. And if you're familiar with substitution, then hopefully you should see that if you set u to be equal to cos x, the differential of that is minus sin x. When you end up subbing this in and replacing your dx, you'll divide this whole thing by the differential of this. So you'll divide this whole thing by minus sin x. The minus sin x cancels out with this minus sin x, and then you're just left with ln u, which you can then integrate without too much difficulty. If that doesn't make sense, let's just run through the steps and you'll hopefully see why. So differentiate this, du dx would be minus sin x, and then switch these two things around, the dx and the minus sin x, and this then becomes dx is equal to minus 1 over sin x du. So now we can sub this in, so this becomes minus the integral of sin x times ln cos x, which is now ln u. We set u to be cos x. And then times that by dx, which is this, so the times by minus 1 over sin x du. Simplify. This 1 over sin x cancels out with the sin x, and the two minuses cancel out as well. This then becomes just the integral of ln u. And now we can integrate this using integration by parts. So if we were to set u to be equal to sec x, in the end you wouldn't end up with this, it'd be a bit more complex. So it'll be a bit harder to integrate. But it is possible that way. Okay, so integrating ln u, I'm just going to rewrite this on the right hand side as the integral of ln x, just simply because in the integration by parts formula we're using u and v. We already have a u here, so that might get a bit confusing. So whenever we're integrating ln x, we would use by parts, and we would set u to be ln x and then v dash to be 1. So this is basically the same thing as ln x multiplied by 1. So ln x differentiated would be 1 over x, and then v dash integrated, 1 integrated, would just be x. Put this in the formula, so the formula is u times v, x ln x, minus the integral of v u dash, so v times u dash, which is just x ln x minus, so x times 1 over x would just be 1, so minus the integral of 1, which is just x ln x minus x. X ln x minus x plus c, therefore this will be u ln u minus u plus c. And then we just replace the u with cos x ln cos x minus cos x plus c, which would be our final answer.